Okay, here's a video for the Algebra 1 final study guide. I'm going to go over each of these questions. It's going to be a lot of stuff, but let's go through it. Okay. The first couple of questions is on graphing quadratics. There were like 6 different steps that you had to follow, and it's pretty simple. You just got to get used to following these steps, right? So every quadratic function kind of follows this format: ax squared plus bx plus c. And so when it says identify a, b, and c, those are the numbers that are in those positions, right? So for this one, find the following information about the graph. A is 1. If there's no number in front of it, it's a 1. B is 6, and C is 11. Okay. Does the parabola open up or down? Remember in class we talked about how if A is positive, then it opens up. If A is negative, then it opens down. Okay, so this one, A is positive. It's positive 1, so it opens up. Okay. Axis of symmetry, how do we find that? You use a specific formula every time. It's x equals negative b over 2a. And so I know my b is 6, so negative 6 over, I know a is 1, so negative 6 divided by 2, that's negative 3. So what does this axis of symmetry tell us? I'm going to create a dotted line at negative 3. And that's where my parabola, that's like exactly the middle of my parabola. Okay, so I know it's going to start somewhere on this line. I know it's going to start somewhere on this line. But where do I know where it's going to start? That's where I have to plug in negative 3 into my equation to get the vertex. So it's going to start on one of these y coordinates, right? So I got to figure that out. Let's plug it in. It's negative 3 squared plus 6 times negative 3 plus 11. Negative 3 squared is 9. 6 times negative 3, negative 18 plus 11. Negative 9 plus 11, that's 2. So I have my vertex at negative 3 and 2. So it's going to start right there. Any additional symmetric points? This is the part where it's kind of like the y-intercept. Do I have my y-intercept here? Yes. Remember, y-intercept is when x is 0. So if I plugged in 0 here, it's just going to be 11. But 11 is off the graph, so I'm not going to consider the y-intercept. The y-intercept is 0 and 11. Let's just start plugging in some of these points next to it. I'm going to plug in negative 2. What happens when, let's write that down. When x equals negative 2, y is equal to negative 2 squared plus 6 times negative 2 plus 11. That's 4 minus 12 plus 11. That's negative 8 plus 11. That's negative 3. Sorry, that's positive 3. So at negative 2 and 3, we have a point. It's an axis of symmetry. So whatever you have on one side, you got to do the same thing on the other side. Okay. Let's plug in negative 1. When x is negative 1, where does my point land? Negative 1 squared, that's 1. 6 times negative 1, negative 6, plus 11. 1 minus 6, negative 5, plus 11, that is 6. So at negative 1 and 6, we have a point right there. We have another one on the other side right there. Okay, that's the best I'm going to get. So let's just kind of like try to guess where the other ones are. You could also plug in 0 if you want. 2 minimum. 2 minimum. Okay. Sorry, here's some stuff outside. That's weird. Find the following information about the graph. Y is equal to negative x squared minus 6x minus 8. So let's do this again. This time a is negative 1, b is negative 6, and c is negative 8. So we got all negative numbers. Does the parabola open up or down? It's negative, so it's going to open down this time. Axis of symmetry, let's go ahead and plug it into the formula. Negative, -6 over 2 times -1. That's +6 divided by -2, so that's going to be -3. So I have my axis of symmetry in the same place again. -3, it's going to pop it up. Okay, and then vertex, again, plug it into the formula. This is where it gets a little bit tricky. I'm going to plug it in directly. Exactly, okay? So negative, right? The negative comes first. And then my x is -3. So -3 squared -6 times -3 -8. I need to follow order of operations, PEMDAS. Right? Parentheses, exponents, multiplication, division, addition, subtraction. So I see this negative and negative here. Before I even change anything, I need to do the exponent first. -3 squared, that's going to be 9. So this is going to turn into -9, right? Because it turns into +9, but then there's a negative there. -6 times -3, that's +18 -8. So -9 plus 18, that's +9. +9 minus 8, that's 1. So our vertex is at -3 and 1. -3 and 1. So right here. What are some symmetric points? So remember, it's going down this time. If I plug in 0, I know my y-intercept is -8. So I have y-intercept at 0 and -8. So I could plot my point there first, -8, and then I want to do the same thing on the other side right here. Let's try to get some of these, some of the closer ones. Let's look at, let's try -2, right? When x is -2. I'm going to plug it into the equation. Y equals -2 squared -6, -2 -8. -2 squared, that's 4. So -4 plus 12 minus 8, that's 0. Right, so we have a coordinate at -2 and 0. -2 and 0. Do the same thing on the other side. Let's do one more. -1. When x is -1, what is that going to be? -1 squared -6, -1 minus 8. -1 plus 6 minus 8. 5 minus 8, that's -3. So I have a point at -1, -3. -3 right there. And then on the other side, same thing. Here's my parabola. Okay. So I got some practice graphing parabolas. We had a whole different worksheet on the other one. And I also posted a video on the other one. Okay, so if you want more practice on graphing parabolas, look at the other video, please. Okay. All right. Let's keep going. Number 3, here's a graph of a quadratic function. Select all equations that could define the function f. So this is kind of going backwards. Now we have a parabola, and we're asked to figure out which one of these equations represent that parabola. Here we had the equation, and then we had to draw the parabola. Okay, so it's going backwards a little bit. I want to notice, I want to write a couple of things here. I notice that the parabola crosses the x-axis at these points, -4 and -2. So that means that we have x-intercepts. I'm going to write that down somewhere. I'm going to write that down right here. X-intercepts are -4 and 0 and -2 and 0. Okay. And then the vertex is at -3 and -1. So from that information, I'm trying to look at which one of these equations. I have to remember, if I want to get my x-intercept, it needs to be in factored form or standard form. It has to be in factored form, right? Factored form. So that means it's gonna be either one of this one or this one. So which one of these factored forms tells me my x-intercept is -4 and y and -2? Right, so let's try this one. I have to set that equal to 0, x minus 4, x minus 2. Remember, when both of them are equal to 0, you could just kind of do this. Oops. X minus 4 equals 0, x minus 2 equals 0. And then just solve for x. Plus 4, x equals 4. Plus 2, x equals 2. So this tells me there are x-intercepts at 4, 0 and 2, 0. Is that true? Do we have x-intercepts at 4, 0 and 2, 0? No. Right? So that one is not correct. Okay, that one's not correct. Let's check this one. If I set this equal to 0, x plus 2, x plus 4, again, I can split them up. X plus 2 equals 0, x plus 4 equals 0, minus 2 minus 2. Then you get x is -2, minus 4 minus 4. You get x is minus 4. This tells me I have an x-intercept at -2 and 0, and then another x-intercept at -4 and 0. So yeah, this one's good. Okay, so this one represents that graph, that parabola for sure. Okay. Another thing we want to check is the vertex. How do we find the vertex? Right, we have to find the ABC, use the axis of symmetry, and plug the axis of symmetry into the equation to get our y coordinate, right? So when we're looking at the graph, we know the axis of symmetry is where? Right? Where is the axis of symmetry? Yeah, -3. Okay, so I know if I plug in -3 to each of these, I wonder if I'm going to get -1 as my vertex. So let's try it out. Oops. I'm just going to erase that. There you go. Okay. So this one, if I plug in this one, we haven't studied before. This one's called the vertex form. So I forgot to take this out on the test. So don't even worry about that. Sorry about that. I forgot to take it out on the study guide. It's not going to show up on the test. But let's try to plug it into this. If I plug -3 squared plus 6 times -3 plus 8, I need to see if I get -1 to get my vertex. Okay, 9 minus 18 plus 8. 9 minus 18, that's -8. Yeah, okay, I get -1, so that one's good. Let's just check this one as well. -3 squared plus 6 times -3 minus 8. Again, that's going to be -9 minus 18 minus 8. No, that's clearly not -1. So this one doesn't work. Your two correct answers here are C and D. Okay, so this is going backwards. You need to be able to look at the parabola, figure out which one of these, like what information can I get? I see my x-intercept, I see my vertex, I see my axis of symmetry. Axis of symmetry, right, is x equals -3. And then based on that information, try to deduce that and pick the answer choices, right? Once you get this, you could also just kind of distribute, right? X times x, x squared, x times 4, 4x, 2 times x, 2x, and then 2 times 4, that's 8. X squared, 4x plus 6, 2x is 6x. Wait, that's what I had right there. So you could also say that's correct that way. Okay, up to you. Okay, for each expression, write an equivalent expression by applying the distributive property. Okay, we've done this in many different ways. We've done the area model. We've done the FOIL model. I'm not going to show you both methods in each problem. I'm just going to show you one method at a time. I'm going to do FOIL model first. This is the model that I learned. I'm not going to go over it in too much detail as well, Again, I'm pretty sure I made a video on this. I don't remember. I made too many videos. So you take this term, multiply by that. So that's going to be x times x. That's x squared. I take x, multiply by positive 10. That's 10x. Now I multiply the negative 9 to the x, minus 9x. Negative 9 by the 10. That's negative 90. I have some like terms I can simplify. X squared plus 10x minus 9x. 10x minus 9x, that's just 1x, right? Minus 90. That's it. That's your answer. You could do that. Or if you like the area model better, so you take those numbers and you put them in a box. And you take 6x and negative 18 here. And you just multiply. 6x times x, that's 6x squared. 6x times negative 8x, that's negative 40. Is it 48? Yeah, negative 48x. And then 18x, negative 18 times x, that's negative 18x. Negative 18 times 18, negative 8, 64. Why is it doing that? 64, that's 144. So positive 144. And then just start adding all of these numbers up together. So we're going to get 6x squared minus 48x minus 18x plus 144. So that should be 16, 66, and then positive 144. That's your answer. Okay. All right, let's try the next one. X minus 6 squared. You rewrite that as x minus 6, x minus 6. You're multiplying it by itself twice. So, okay, I'm going to pause here for a second. I want you to try this out. Okay. All right, I'm going to do whatever. I'm just going to do FOIL method. X squared minus 6x, and then negative 6x again, and then negative 6 times negative 6, that's positive 36. I can combine negative 6x minus 6x, that's going to be minus 12x. That's it. That's your answer. This one is a little bit confusing. Let's try this one. I want to go from left to right. I'm going to start with this. 6 times x, 6 times 9. 6 times x is 6x, and then 6 times 9, that's 54, right? But I'm still going to put that in parentheses. Because if you don't do that, you're only going to distribute, it looks like you're only distributing the 54 again. That's not true. You want to distribute the entire thing. So I'm going to FOIL one more time. I'm going to do 6x times x, 6x squared, 6x times 4, 24x, 54 times x, that's 54x, and then 54 times 4. That is 216. Add the numbers up. 6x, that's 8, 78x, and then 216. There you go. That's it. Just practice distributing. This is really important for you to know when you move on to your next classes, whether it's geometry, algebra 2. Okay, let's keep going. Whoa, how many questions? Whoa. Dang. We're halfway done. Factoring. Right, we're going to factor each quadratic expression, show all your work. So, let's factor this one. Remember, we have to use the n term and then the coefficient, right? And you have to remember what to put where. So I'm doing the diamond method. I have to put the negative 40 on top, and then the coefficient on the bottom, because the top is the product and then the bottom is the sum. Okay, you just have to remember that if you put negative 40 in the top, in the bottom, then it's going to be wrong. So we're trying to think of two numbers, negative 40, that multiply to get negative 40, right, product, and then add up to get negative 3. Okay, so I'm just going to list some numbers. Negative 2 times 20, that gets you negative 40, but do they add up to negative 3? No, that gets you negative 7 or positive 17. You could also do 20 and negative 2, but then that's still positive 18. Oh, I meant to say positive 18. My bad. Or, sorry. Wait, you could do this, negative 20 and 2, but that's going to get you negative 18. Let's keep going. 4 and 10, negative 4 and 10, that multiplies to get 40, negative 40, but that doesn't add up to negative 3. So the other one's probably not going to work as well. What about 8? Negative 8 and 5. Negative 8 times 5, that's negative 40. Negative 8 plus 5, yeah, that works. That gets you negative 3. So my two factors are going to be x minus 8 and x plus 5. And those are my two factors. Okay, just keep doing that. Negative 15. Oops, see, I made that mistake. Negative 15 on the bottom. And then 50 on top. So what are two numbers that multiply to 50? I mean, I'm thinking 5 and 10, right? Negative 5 and negative 10. Again, negative 5 times negative 10, that's 50. Positive 50. And then when you add them up, you get negative 15. So that works. Negative 5 and negative 10. There you go. That's it. It's pretty simple once you get the hang of it. Negative 12 for, let's see, negative 12. What are some factors of negative 12 that add up to 4? I'm thinking 6 and 2, right? Negative 6 and positive 2. That gets you negative 12, but then if you add them, that gets you negative 4. So maybe it's the other way around. Maybe it's negative 2 and positive 6, right? And yeah, that makes sense. So our factors are going to be x plus 6, x minus 2. Last one, 14, right? 14 on top, 9 on the bottom. Immediately, I'm thinking 2 and 7. 2 times 7, that's 14. 2 plus 7, that's 9. Okay, cool. Let's keep going. Two equations, y equals x plus 2 times x plus 3, and y equals x squared plus 5x plus 6 are equivalent, right? How do I know they're equivalent? Because I could either factor this out and get this, or I could distribute that and then get that, okay? So it's the same thing. What is the x-intercept? Which equation helps find the x-intercepts most efficiently? Remember, this is factored form, and this is standard form. Okay, x-intercept, we're going to use factored form. Okay, remember, we did this earlier. We set that equal to 0. We use factored form for x-intercept. Right, we have to set it equal to 0, x plus 2, x plus 3, right? And then now split them up. X plus 2 equals 0, x plus 3 equals 0, and then just solve for x. Minus 2, minus 2, minus 3, minus 3. So those are your x-intercepts. At negative 2 and negative 3, the parabola is going to cross the x-axis. The next question, what is the y-intercept? Which equation helps find the y-intercepts most efficiently? That one was the standard form, right? Because all you have to do Y-intercept means you set the x equal to 0. X-intercept means you set the y equal to 0. It's way easier to find the x-intercept on this, because if you set y equal to 0, you just have x plus 2, x plus 3. Here, if you set y equal to 0, then how are you going to solve for this whole thing? That's pretty difficult. Okay? Anyways, so this one, the standard form, we're going to use the standard form for the y-intercept. So we use standard form, and it's pretty easy, right? You just set y equals, and you set the x equal to 0 this time. Set x equal to 0. And then this one is set y equal to 0. Okay. It's 0 squared plus 5 times 0 plus 6. Right? Yeah, there you go. 0 squared is 0, 5 times 0, 0, so it's 6. So your y-intercept is at 0 and 6. And then this one, sorry, I forgot to put them in coordinates. This one is negative 2 and 0, and this one is negative 3 and 0. Cool. Here, a quadratic function f is defined by f of x equals x minus 7, x plus 3. Without graphing, identify the x-intercepts of the graph. Explain how you know. We use factored form. Same thing, right? Set y equal to 0. Here, this is also considered a y. You can rewrite that as y. It's the same thing. Okay, so y 0 equals x minus 7, x plus 3. Split them up. X minus 7 equals 0. X plus 3 equals 0. Plus 7 minus 3 minus 3. That's it. So we have two x-intercepts at 7 and negative 3. Expand that and use the expanded form, which is also called the standard form, to identify the y-intercept. Okay. So we're going to expand it. I'm going to FOIL x squared, x times 3, 3x, negative 7 times x, negative 7x, negative 7 times 3, that's negative 21. So then 3 minus 7, that's minus 4x. So this is my standard form. And if I plug in set x equal to 0, what happens? 0 squared minus 4 times 0 minus 21. That's just negative 21. So we have our y-intercept at 0 and negative 21. Okay. Number 8, what are the x-intercepts of the graph of the function defined by that? Same thing, right? We've practiced this 3 times now. Set that equal to 0. And let's go ahead and solve for x in each of them. Split them up. X minus 2 equals 0. 2x plus 1 equals 0. Plus 1 plus 2 plus 2, that's x equals 2. So I already know that one of my x-intercepts is 2, 0. So that's wrong, that's wrong. And then the other one, it's a couple extra steps, but that's fine. 2x equals negative 1, right? Because negative 1, negative 1. And then divide by 2. Divide by 2. Those cancel out. X is equal to negative 1/2. So then our x-intercept for the other one is negative 1/2. That's going to be this one. Okay. So now I told you guys that we would have exponential function on the final, right? We could have exponential function on the final. So let's go over some of these questions. A computer costs $1,000. It loses 1/5 of its value every year after it is purchased. Complete the table to show the value of the computer at the listed times. So when we bought the computer, it costed $1,000. It loses 1/5 of its value. So every year we want to find out how much it's worth. So if it loses 1/5, it's worth, what's the remainder of 1/5? That's how much it's worth, right? If it loses 1/5, that means what's 1/5 of $1,000? That's 200. So it loses $200 in the first year. But I don't want to know how much money it loses. I want to know how much money it's worth, how much money is left over, right? So the leftover factor is 4/5. So if I multiply 1,000 by 4/5, that's going to get me how much money was left over after you lose that 1/5. Okay, so that's going to be 800, right? And then every year, keep multiplying by 4/5. 800 times 4 divided by 5. That's 640. And then multiply by 4/5 again, times 4 divided by 5. Now it's 512. What if I go backwards, right? What if I bought